Hi everyone, and congratulations on finishing this module. Before we go on to the new module, I just would like to review to us, remind us that in this module we'll learn mainly about the sun, our star. We explore the photosphere, which is we can think of the main surface of the sun, where most of the light from the sun that we've seen originated. We also touch base on the chromosphere and the corona, and we explain how the temperatures in the corona is actually a lot hotter than the temperature at the surface of the sun, the photosphere. And it's kind of strange because in the corona you have less number of molecules per unit volume than the photosphere, right? And the reason, as we seen, it was that is due to magnetic field or magnetic loop activity that can accelerate particle to go at faster and faster speed, hence manifest in higher temperatures. We also seen granulation on the surface of the sun, and we know that those are caused by convection current, basically hot gas rising up, cool down, and rising up and cooling down again. And then we also learned about the solar wind. We understand that when you have a sunspot or when you have magnetic tube juggling in and out of the photosphere, sometimes those things can break, okay, because of instability, and it manifests in solar flare and coronal mass ejection, and those things right there on top of particle just escape from the sun give us the solar wind. And we also learned about sunspot, that we know that sunspot is a result of magnetic phenomenon on the sun, where it kept the gas in that region to be less than the surroundings, so hence lower temperature. And as you have lower temperature, it looks darker than the surrounding right there. And we also did an exercise on the sunspot cycle, when we see that the cycle going is about 11-year cycle, when you have every 11 years the sun peak in the number of sunspots per year, and then it trough 11 years and peak later right there, right? And these cycle right here can influence weather and climate on Earth. And we also learned about the spectrum, the atomic model of atom, and how each individual atom has different electronic level. When light from the sun or a star interact with that, it can generate different light pattern. We call that spectrum right there, right? Spectral analysis. So different atoms give off different spectral pattern, and we can use that to analyze and figure out which atom is in the star and which atom is not. And we realize that the sun is mostly composed of hydrogen and helium right there. Now, in fact, helium is first discovered by doing the spectral analysis and looking at the sun right there. So before we go on to the next module, I just want to make sure that you, if you have not understand it yet, review this concept, go back to look at your exercise, go back, look at the discussion to learn more detail about this right here, because we're going to build on this knowledge right here. And as we head into the next module, when we're going to use this information and knowledge and foundation from here to generalize, extend what we understand to other star. For example, star in the HR diagram, star in our galaxy, and star in the universe. That you can have some stars more massive than our sun, less massive than our sun, but the underlying foundation and basic right here should carry through to our next module and to on your star in other part of our universe right there. Right. So if you have any, congratulations on finishing this module. If you have any question, feel free to email me, Zoom me, and I'll be glad to answer help you anytime. Right? Have bye bye.